All right, February 2nd lesson, part 2, take 2. So this is on page 69. Okay, and this is example 3. I know we sort of skipped this little bit here, but we talked about it before anyway. So here we are. We have this little blue box that we are measuring. And in terms of what our smallest division is, well, this is 1, this is 1.1, this is 1.2. Okay, so the smallest division is 0.1. So we can estimate to the 0.01. Now our little blue box appears to be right here. So this would be 0.5, 0.6, 0.7, 0.8. So our length is equal to 0.8 centimeters. However, we're sure about that 0.8. There's no way that that is perhaps 0.7 or 0.9. So we're sure about that. We have to estimate one digit more to that 0.01 position. So it is going to be 0.80 centimeters. Are we sure about the 8? Yes, we are. Therefore, the 8 is a certain digit. And remember, all of your certain digits are significant. So the 8 is significant. Are we sure about the final 0? Well, no, we're not absolutely sure. If I zoom in here really close, let's see if I can make it zoom. Zoom. I actually think that maybe I might guess that that is 0.79. It could be 0.79. All right. So we are not sure about that final 0, and besides which our hundredths position is one more place value than our smallest division. So no, we are not sure about the 0. So the 8 is certain. The 0 is uncertain. And then there just remains the question of that 0 at the beginning. Now what that 0 at the beginning tells us is that there is no number in the ones position. There is no number in the ones position. It is essentially telling us that our number hasn't started yet. I could just as easily have written 0.80, in which case that would mean I have 0 tens, I have 0 ones, and I have then my certain digit and my uncertain digit. I could have also written 0.80, which would mean I have no hundreds, I have no tens, I have no ones. Okay, so no hundreds, no tens, no ones. And so those digits at the beginning are really actually meaningless because, I could carry on writing them to the left forever. They just tell us our number hasn't actually started yet. It doesn't start until we get to the 0.1 position. So there's no number in the ones position. This 0 just tells us our number has not started yet. And therefore, it is that digit, that 0, this one here, let's highlight it in maybe blue. Okay, this 0 here is not significant. That 0 on the left of the number is not significant. Okay. And that's actually going to be one of our rules, is that zeros to the left of The rest of the number are not significant, and we'll come to that in just a little bit. Now, I've actually blown up this object, and I made these little blue boxes a little bit different from one another. So actually this little blue box on the left is a little bit different from this little blue box. I don't know if you can even see it probably on your sheet. This one is actually a little bit smaller. If I was really guessing, I might say 0.79 centimeters. This one is a little bit bigger. This one I might tend to guess 0.80 centimeters. And then what have I done with this last one? I don't know what I've done with this last one. That's a mystery to me. I made some sort of difference, but I don't know what it was. And in fact, if you zoom out on these to something resembling a real actual centimeter, there is no way on earth you'd be able to tell the difference between any of these three boxes, okay? And what this is called in science is this is called a random measurement error. Yes? If I zoom way in on this one, I can see that maybe it's probably more like 0.79, but if I'm not zoomed in, I might have a tendency to write 0.80. And that's just because of the limitations of my eyes. It's because of the limitations of the measuring device. And so that's what in science we call random measurement error. And it's important in science that we make the distinction. Error in science does not mean a mistake. Okay, so this is not a mistake. Error in science does not mean a mistake. When we say mistake in science, we just say this was a mistake. It simply means that we cannot make perfect measurements. Okay, there's no way we can make a perfect measurement. Our rulers are not perfect. Somebody had to make them somewhere. They were manufactured. Super hard to manufacture everything absolutely perfectly. And our eyes are not perfect. We simply cannot see that well. So when we say there is an error, we mean that we cannot make a perfect measurement. So a scientific error is simply the difference between what we observe, between the observed values, in other words, between our measurement and what is true in nature. So if we had like magical powers, we could go and we could say exactly what that thing is measured, but we don't. And so that is why we run into error. No worries. I'm just trying to re-record our lesson from last day. Okay, just a quick pause there. But we are back now, and we were talking about scientific errors, and that those are the differences between our measurement and what the actual true value would be in nature if we could know the exact, say, true length of that little blue box, okay? And if you think about it, if the true value of that little blue box was 0.79 centimeters, and we recorded, if the true value was 0.79 centimeters, and we recorded 0.80 centimeters, then that would be our margin of error, okay? So our scientific error is talking about our margin of error. And what is our margin of error? Our margin of error is our uncertainty, because we could be plus or minus 0.1 centimeters. Or sorry, not 0.1, 0.01 centimeters. Remembering, of course, that our hundredths position is the uncertain digit, and our uncertainty must also lie in the uncertain digit. Okay, so the uncertainty is our error, and the error is the uncertainty. They are one and the same. Okay, so our margin of error is plus or minus 0.01 centimeters. That is our margin of error. That is our uncertainty. And just reiterating, in grade 11, you're not expected to be able to write the uncertainty. That will be an enriched thing should you choose to do so. All right. Next on our list, how many significant figures are in 0.80? We did talk about earlier why we only count the 8 and the 0. It's because this value at the front is just a placeholder telling us our number has not started yet. Next day, we will actually be learning about scientific notation. And when we write this number in scientific notation, 0.80, it actually becomes 8.0 times 10 to the negative 1. And just to show you how that works, if we take 0.80 and I say I want to make that 8.0 times something, because I know I have this digit which is certain and this digit which is uncertain, so I need to have both of those because every number needs an uncertain digit. I could write 8.0 times 0.1. Yeah, that would equal 0.8. 8 times 0.1 is 0.8. Okay, now I could rewrite that as 8.0 times 1/10, because 1/10 is 0.1, right? And I could rewrite that as 8.0 times 1 over 10 to the 1, right? Because any number to the power of 1 is itself, so 10 to the 1 is 10. Okay, so we have 1 over 1 to the 10 to the 1. And finally, I could take that, and because it is in the denominator, I could write it in the numerator and make the exponent negative. So 8.0 times 10 to the negative 1 is the same as 0.80. Now, would we ever write this number? Would you ever write 08.0? Is that a normal way of writing a number? No, it's not. We would always just write 8.0. Why would we bother having a number in front of it? It's just telling us our number hasn't started yet. Remember, this 0 was telling us that our number hasn't started yet. Okay? Don't worry if you didn't catch the scientific notation thing. That's what we're going to be dealing with tomorrow, which is actually today for me. Haha. Okay. All right. So if we have 40, we would not write it as 0.040.0 because that's just silly. Okay, so this number would have 1, 2, 3 significant figures. Okay, which takes us to our first rule about significant figures that we are going to learn today. We will learn the rest of them tomorrow. Zeros at the beginning of the measurement, in other words, zeros to the left of non-zero digits, are called leading zeros. It's not terribly important whether you remember the term leading zeros or you just remember that zeros at the beginning, or whether you remember that zeros to the left of non-zero digits. Whichever way you remember it, those zeros are not significant. So here we have our non-zero digits, 3 and 4, and we have some zeros to the left of them, and those are not significant. So if we were to look at this number here, we would have 1, 2, 3 significant significant figures. And don't worry about the zeros on the right, we'll talk about those later, okay? Here we have 00260. Those ones are obviously not significant. I don't have any thousands, I don't have any 10,000s. My number simply has not started yet. And so this number would have 1, 2, 3, 4 sig figs. And now we are going to just pop very quickly to page 1 and do a quick introduction. This is page 1. And we're going to learn a little mnemonic device. The word meme, the M is silent, mnemonic. Meme, a mnemonic device, is a memory tool. And that's because the Greek for memory is meme. Okay, so there we are, we've got that. So our memory tool that we are going to use is nim. Okay, you'll notice that the N is on the left, the Y is in the middle, and the M is on the right. And so what we have is, if we have a number 0.0560080, the zeros that are on the left, these ones here, those are no. That's why we have our N, no. They are not significant. Zeros in the middle, that would be like these ones. And those are ones that are sandwiched in between some non-zero numbers. It's in between the 6 and the 8. Those ones are, yes, they are significant. And finally, we have a 0 on the right. Okay, and that one, the M stands for maybe. Maybe those zeros are significant. Okay, and when it comes to that maybe, what we're going to have to ask ourselves is there a decimal in the number? So for the maybe, we ask ourselves, is there a decimal in the number? They are significant, those zeros on the right are significant only if there is a decimal in the number. So what you can ask yourself is, you can say, is there a decimal? If you say decimal yes, then you say significant yes. If you say decimal no, then you can say significant, no it's not. So in this particular number, zeros on the left do not count, so we will not count them as part of our sig figs. Non-zero digits are always significant, so we have 1, 2, zeros in the middle, yes, those are significant. 3, 4, that's a non-zero digit. 5, and then we have a final 0, and that's our maybe, and we ask ourselves, is there a decimal in the number? And lo and behold, there is a decimal right there. I've made it large and red. And so if we say decimal, yes, there is a decimal, then is that 0 significant? Yes. So that means now we have a 6th significant figure. So there are 6 sig figs in that number. If that made no sense, don't worry. That was just a brief introduction. We will go over all of this mañana, tomorrow. Thank you for listening.